Welcome to 15th lecture in the course Industrial Engineering and Operations Research. We are discussing about quality engineering and management. In the 11th lecture, I told you about the concept of total quality management and mentioned the contributions of some quality gurus like Deming, Juran, Ishikawa, etc. Now in the 12th lecture, basic concepts of statistics were explained because statistics is quite often used in the quality management. Then after that, we give one talk on acceptance sampling, where you take the decision to accept or reject the lot based on the sample measurement. And then after that, we discussed about control charts, which are called on-line control methods. Process is going on, and if you want to do that, so you just have to see that whether something is within the control or out of control. Say for example, you can have X bar chart, you can plot X bar here, this is the, say suppose grand mean, and this is the upper control UCL of that, and this is the LCL. And if your mean of some samples, you take the mean of the samples, if it falls within these control limits, then you say, okay, fine, my process is under control. If sometimes your sample goes out of these limits, then you say process is not under control. So we have X bar, which tells the mean tendency of the mean, and also you have R chart. Okay, so we have R means range. Okay, so within that sample, that what is the range, that also you plot. Okay, so this is the R chart, and here also you can have UCL and LCL. So these type of charts are basically on-line control method. Today I am going to discuss something about Taguchi's method. Taguchi was a Japanese engineer who contributed a lot to quality. Particularly, he was more for even offline quality control methods. Offline means that you have to, not that during the process when the production is started. He used to say that the quality should be introduced from the very beginning, even at the design stage, and then after that it should be pursued later on. He gave the concept of that basically quality is a loss to society. If you know your quality is poor, it will cause loss to society. In fact, you can measure in terms of the financial loss also. So he also gave one concept about the full factorial array. Of course, it is not that he invented that, but he made use of these full factorial array type of thing. That means it is a way to understand the response of some factors on the performance. Okay, say for example, you want to see that cutting speed, feed, and depth of cut, okay, how do they affect surface roughness. So you can say, okay, A means A may be cutting speed, and B may be feed, and C may be depth of cut in machining. Okay, on that depends, maybe you can say surface roughness. Okay, so maybe surface roughness, we can say SR is dependent on that. Surface roughness you measure, suppose it is dependent on that. So we say cutting speed, feed, and depth of cut, they are the factors. You can name them also. You can say cutting speed is A, feed is B, depth of cut is C. So these are the factors. And response means you can have surface roughness as response. So we can say this is as response. Okay, SR, surface roughness, whatever is that thing. If you are measuring cutting force, then cutting force becomes a response. Now what happens that you have to understand the effect of these factors on surface roughness, then you need to conduct experiments. So Taguchi said that okay, it can be done in full factorial way also. That is one way that we do full factorial way, but we can also do fractional factorial way. Let us discuss the full factorial way. So each factor has some level, okay, like cutting speed has got two levels. One is the low level, that means low cutting speed, other is the high level. Similarly, feed has got level, low feed and high feed. Depth of cut can also have level, that low depth of cut and high depth of cut. And we can designate in terms of the number, that here I can say low level speed I can designate by -1 and high level I can indicate by +1. Please understand that this -1 and +1 is not in the strict arithmetic sense. That means my -1 may be 200 rpm and +1 may be 300 rpm. That type of thing can be this one. Or in terms of the cutting speed, meter per minute, so -1 may be 90 meter per minute, +1 may be 150 meter per minute. Similarly, about the feed and depth of cut, so we are just designating -1 means low, +1 means high, maybe some intermediate value we can code it by 0. So like that we are coding that. So suppose we assume that cutting speed, feed and depth of cut, this is, we take it at all three of them, we take at two levels, high level and low level. So therefore cutting speed can be chosen any experiment. How many ways? Two ways. Similarly, feed can be chosen with that cutting speed fixed at 2 ways, and this depth of cut also can be chosen in 2 ways. So total number of ways are naturally 2 into 2 into 8, means these are the factorials. Okay, that means we can have total 8 experiments. Then it will cover all the combination. That means one combination may be cutting speed, feed, depth of cut is high, all of them are high, another may be all of them are low. Then there may be other situations that one is high, other two are low, like that. So this is depicted here, that we can have total 8 experiments and distinct experiment, and they are like that. -1 means all of them are low, -1 +1, that means two are low and this is high, like that. 8 means +1 +1, that means all of them are high. And we can also understand their interaction. I am just indicating, suppose A class B. So A class B means suppose both are low, that is one type of level, and both are high, that is also one category, +1, -1 is +1 and this is also +1. So both low is one thing, both high is one thing, but one high and one low I have indicated -1, because this is something in a different way. Okay, that means, so this will be helpful for me to understand the interaction effect. Okay, interaction effect, these two parameters. That means one thing is that cutting speed, suppose you say that increasing cutting speed reduces the surface roughness, and similarly increasing the feed, suppose increases the surface roughness. But how that if one is increased and the other is decreased, then what will happen? That's why we have done A class B column. And B class C, similarly this thing, +1 -1, when both the values are same way, then we designate it by plus, and when one is high, one is low, then we indicate by minus. Similarly, we say C into A, that means interaction effect of C and A. So they interact this one, and interaction effect of the combined thing A, B, C. So suppose all are low, that is -1, and then all are two low and one high, that also is +1, like that we have done. Okay, so and then we measure naturally the surface roughness at each experiment. So we have done 8 experiments here. So here what is happening, that we are doing total 8 experiments. If we have each parameter at 3 level, then the number of experiments required will be too much, that will be 3 to the power 3, that means 27, because low, mid, high and medium each one. So 3 into 3, 27. Similarly, if we have 4 parameters, so 4 by 3, 4 power 3 means 64. So in this case, you see very well that here why I am carrying 2 to the power 3 full factorial analysis, because 2 is the level and 3 is the factor. So factor comes on the exponent. Now if we make this type of table, let us say we have made table of the only linear effect, then effect of a factor can be said that response at level 2 of the factor minus response at level 1 of the factor divided by half the number of experiments. So what does it mean? If I want to see the effect of cutting speed on the surface roughness, so at all low values of the cutting speed, I must measure that surface roughness and sum them. Similarly, at all high values of the cutting speed, I added and the surface roughness edge and took the difference of both and divide by 4, because there are 4 high, 4 low. So this will give me effect of a factor. So like that we can calculate this one. And if we want to find out quadratic effect, then we can have, suppose a middle level is there, that is level 3, that is in midway, intermediate level. Then we have formula sigma response at level 2 minus 2 sigma response at level 3 plus sigma response at level 1 divided by 1/3 the number of experiment. So this will indicate to me that whether there is any quadratic effect or not, or it is only linear. So that's what that we will be doing. But you know, Taguchi said that okay, this type of procedure may take a lot of time. So if we take the fractional factorial array, for example, instead of having 8 experiments, let us decide to do only 4 experiments. So he gave the concept of orthogonal array. Orthogonal arrays have some property. The name is derived from that thing, that two orthogonal lines, okay, they are having some properties, and something that you cannot obtain one orthogonal line by scaling the another line, okay, means both things are different. That is, one line is this, another line is this. Of course, intermediate thing, if I want, suppose this line, it can be written as some combination of this direction and this direction. So that's how the name orthogonal came anyway, but it is not much important in this context. It is only that you consider that it is a fractional factorial array, and it is based on some type of thing that, you know, say suppose we are doing 4 experiments. So we are having now a factor at 2 low and 2 high. So same behavior should be done with B also. B should be 2 low, 2 and 2 quantities high. Okay, this is high side. Similarly C, and like that. So how do we decided that I can make even 4 experiments? We noted that suppose ABC is +1 +1. If we think that all the 3 factors interact in very insignificant way, that means it is not our target to study that A plus A into B into C, or in a simple word, your formula can be made by Y is equal to something C1 times A, C2 times B, plus C3 times C, plus C4 times A class B, plus C5 times B class C, plus C6 times C class A, but you don't have any term of A, B, C. So probably you need not see that what happens with +1 and what happens with -1. So all the +1s have been taken, and then you got this table, and similarly you can have other one. So only this much is good enough, and you can get inference by 4 experiments only. So this is the way that he has suggested one way. Then he gave, of course, the concept of a loss function. Taguchi said that quality is basically lost to the society and customer. So how he illustrated that, suppose you have some dimension has to be produced, some shaft is produced, and it is at this dimension, that target is T, but let us say you have customer tolerance, customer is happy to take even if it is T plus D and it is T minus D, but beyond that he will be unhappy. So Taguchi said, okay, fine, you if he may be happy by it after taking T plus D, but even if you are making at this dimension, so although the customer will accept, but you should consider that it is basically the loss. You should always try to make the target. So he said that it is a continuous function and a loss of that some item y is equal to dimension md square y minus t square. So y is my variable. So suppose y is equal to t, if dimension is coming equal to target, then of course the loss is 0, there is no worry. But if it is deviating, suppose then there is a too much loss, okay. So how do you say that? Suppose if you put y is equal to t plus d and this is minus t, so naturally that t plus d minus d, so that means it will become t plus d minus t, t will cancel, it becomes d, and this is d square, so d square, so loss becomes m. That means total loss is basically m. So how do you determine that m? D is known by suppose design specification or by customer one, but how do you decide? Maybe you can consider like that, that suppose you are making some object and that object is costing about say 3000 rupees, and that 3000 rupees go away. That means it is loss because customer will reject. You can tell that okay, if he rejects, then you get a loss of 3000 rupees. So you can put that 3000 rupees here, and you can say that other things you can write a function. So this is the type of that concept Taguchi gave. And sometimes it is not that we want target, but we want something larger the better, okay. And sometimes we want smaller the better. Suppose the thing is that smaller is the better, then loss can be specified as ky. In that case target is 0, ky square. More you are away, then it is this one. And similarly it can be other way around, 1 by ky square. Like that you can make different type of losses, okay. That means depending because in each case you can make a target. So this is what that Taguchi said. So you should always try to make keep minimum deviation. So naturally motivated by the same thing that Six Sigma concept came, that means it is again emphasizing that thing that there should not be too much variation and in fact defects etc. because we talk about in statics way. So earlier we used to say within plus minus 3 sigma limit 99.73% data false. So therefore target that everything should be within plus minus 3 sigma. So he said that Bill Smith and Michael Harry said no, it should be plus minus 6 sigma, and therefore 6 sigma concept came. But 6 sigma is not only for loss etc. or it is something statistical deviation, rather it is telling some methodology also. So 6 sigma was developed by Bill Smith and Michael Harry, both engineers at Motorola in the 1980s. Specifically, Smith is often credited as the father of 6 sigma for first coining the term and identifying the need to set specific improvement goals based on defect measurement. That means he put the goal also. It is a high performance data driven approach for analyzing the root cause of business processes, problems and solving them. It links customer, process improvements and financial results. So sigma basically is a Greek alphabet. We know that sigma is written like this, and in statistics it is used to measure the standard deviation. More specifically, sigma measures the capability of the process to perform defect-free work. A defect is anything that results in customer dissatisfaction. Defect need not be that only manufacturing defects. We can have defective component defect, wrong shipment also, delayed delivery also is defect. So sigma value indicates how often defects are likely to occur. Now suppose many manufacturing companies process operate at 3 sigma level, which basically translates into 67,000 defects per million, while service company processes are often at 1 or 2 sigma level. That is, in one case 1 sigma level 6,90,000 defects per million, and in another case 3,08,000 defects. So in one case 6,90,000, other case we have 2 sigma level means 3,08,000 defects per million. We have that type of thing. If you are too much specific that how this figure of 67,000 defects per million has come in 3 sigma, then you can see the standard normal distribution curve and you have to see the area. We assume that the process is 1.5 sigma shifting may be there. So therefore mean is placed here and we see area between plus 1.5 sigma and minus 1.5 sigma, and beyond that is the defect. So like that we calculate. Okay, if you want you can see, say for example when we talk about 6 sigma, then we see the area under the curve of a normal distribution between minus 4.5 sigma and plus 4.5 sigma, not precisely between minus 6 and plus 6, but minus 4.6, all within 4.5 standard deviation of the mean, because of we consider that 1.5 deviation can be there. So it represents approximately 99.99966% of the total area, and this corresponds to 3.4 defect rate per million opportunities. Per million opportunities means where the defect can occur, which is the basis for the 6 sigma methodology. So 6 sigma methodology is that, like it is called DMAIC method. Define, first to define the problem or something and then measure, then you do analysis, you do characterization, and then improve the process and control. That part is called optimization. This type of procedure you have to follow. Now little bit some mathematics associated with 6 sigma thing. Okay, we will say that defect per unit. Okay, so defect per unit is that defined as total defects divided by total unit produced. So for example that I produced say 100 unit, okay, but I got one defect, so my defect per unit will be 1 by 100, okay, or it will be 0.01. So this is defect per unit. Another important term is that defects per million opportunities. That opportunity is what, where the defect can occur, that here there is opportunity for defect to occur. So how do we calculate? Here DPMO is total defects in the similar way, but total units and opportunities per unit. In each unit there 3 ways defect can occur. So therefore it will be 300 and multiplied by per million opportunity. That's why you multiply by 1 million. That means it is 10 lakh. Okay, 1 into 10 to the power 6. So here what happens, DPMO, suppose I am making 100 units and in each unit there can be 3 defects. Okay, let us say that we have got 3 dimensions which are critical and that is the only way the defect can occur. So naturally either this dimension incorrect and other 2 are correct, or all 3 are correct, like that. So there are 3 type of defects can occur, means 3 dimensions may go wrong. So opportunities per unit is 3. So here if you want to say that total defect, suppose out of 100 pieces it was 1, so and 100 into 3 and into 10 to the power 6. Okay, so like that. Then there is a third important term is that called, that is yield. So we say yield is equal to 1 minus defective units divided by total units into 100. Okay, so that is the yield. So suppose defect per unit is 0.01, like that. So we can say 1 minus and now defective unit. Okay, so here basically it is unit, it is the total defects here. Okay, defect may be in some unit also there can be 2 defects also, so that also has to be counted there. Okay, but here it is talking about defective units. Let us say we are making 50 units and 1 unit is totally defective. So 1 minus 1 by 50 into 100. So therefore it happens that this becomes okay, this becomes 49 by 50. Okay, so this is into 100. So 50 52, so that means 98. So we say 98% yield is there. Naturally that means your actual production is having 98% yield only, because out of 100 2 units become defective. Okay, please note that this is defective, This is not the defect. Here there is a total defect. Okay, that is. Then we also define that suppose first pass yield, that means it is units with no rework divided by total units processed into 100%. That is called first pass yield. So suppose I don't have to do rework. If I do rework, then it will not be. So first pass yield, suppose units with no rework, I made 50 units and 49 did not need any rework. So therefore units 49 did not need any rework. So 49 into 50 into 100, and this becomes basically again 98. So suppose 98%, or we can say without percentage it is 0.98. Okay, and if there is a multiple steps, then it can be multiplied in this is a symbol for multiplication. I is equal to 1 to n fpy. That means yield in one stage is 0.98, other stage is 0.97, third stage is 0.96. All these can be multiplied, and then finally you can express in terms of the percentage also. So this is the type of equations. One important equation, of course, we also use that. This is process capability index. This is upper specification limit minus lower specification limit divided by 6 sigma. That is called this one. So naturally that process capability index should be very high, and that is what is given. And now let us talk about, so these are the some mathematical things about Six Sigma, but let us tell that how we implement management implements in the shop floor, and in order to enthuse management people that Six Sigma methodology contains these type of belts. Okay, we compare with the martial arts. Okay, in martial arts like karate, etc., you get white belt, yellow belt, green belt, black belt, master black belt. So like that we have here also. White belt, somebody who has got white belt of Six Sigma, that means he has the basic understanding. So then they give that this one, okay, that some agency gives that, you know, basic white belt. Yellow belt means team member on projects that who are actually doing the work on Six Sigma. Green belt means project leaders and who knows that the DMAIC cycle, that design, measure, analyze, inspect and control, improve and control methodology. So that we have told the DMAIC method, define, measure, analysis, improve, control. That methodology one knows, then he will get green belt. And black belt means full-time improvement experts, that they are experts and they are full-time, they are doing the same work. And master black belt will be strategy and mentoring, they will be doing higher level work, and they will be called the Six Sigma. Then I am telling you about some standards, okay, which have been made, like ISO, that is International Organization for Standardization. They have made ISO 9001. Actually it was made quite early, okay, and it was then modified. It was something like last decade of the 20th century, okay, and it got, but now I am only telling the latest one, that another revision was done in 2015. So we have got ISO 9001 2015. If you see many books, you can see ISO 9000 and 2000 colon 2000. Those type of materials are also there, but I am telling this one. ISO 9001 colon 2015, that means revised in 2015, is an internationally recognized standard for quality management system. Like management system should be how much, that is, doesn't mean that you got ISO 9000 then your product will be very good or something, but means you are following proper system. So that certification is given. So it provides a systematic framework to ensure that organizations consistently meet customer and regulatory requirements while improving overall efficiency and performance. So key features of ISO 9001 are process approach. It emphasizes understanding and managing interrelated processes for efficiency, that you must understand the process. Then risk-based thinking identifies and mitigates potential risk in quality management. Then it has a customer focus. It ensures customer satisfaction by consistently delivering quality products and services. So they will check some parameters, those who give the certificate, that whether you are taking customer feedback or not, whether you are documenting or not, what is the method, those type of things. Leadership involvement encourages active participation of top management in quality initiative. Continuous improvement, it fosters a culture of ongoing enhancement of processes. Then evidence-based decision making, it relies on data analysis for effective decision making. As I told, that statistics forms very important point, and nowadays we, instead of statistics, we use term data science, etc. Context of the organization, it considers internal and external factors affecting quality. What are the benefits of ISO 9001 2015? It enhances customer satisfaction and trust. It improves operational efficiency and reduces error. It increases market credibility and business opportunities, because when the other person knows that you have got ISO 9001 system in your organization, it must be, your organization must be good. Ensures compliance with regulatory and statutory requirements. So ISO 9001 2015 is applicable to organizations of all sizes and industries. It may be service industry also, it may be even educational institute also. So making it a versatile tool for quality assurance and business excellence. Now I will also refer to you something that we have got related things like occupational safety and health administration, OSHA, that should also be placed. Okay, if you want to have the total quality management, it is about the health and safety of the people. So it was established in 1970 under the Occupational Safety and Health Act. Agency was US Department of Labor. So they have some key responsibilities. That means they set and enforce workplace safety and health standards. Then they provide training, outreach, education and assistance, and they inspect workplaces for compliance. They protect workers from known hazards. Okay, so these type of things they monitor. So OSHA is also one important thing. And what does OSHA contribute? It reduces workplace injuries and illness. It promotes safe and healthful working conditions, and it empowers employees to report unsafe practices. Means in US, that type of law is there, corresponding laws are in each country. So those type of things are there. And similarly, you can have one ISO 14000, which is about environment, whether your practices are environmentally benign. Those type of things are also there. So this is what that you have to see, that in the total quality management you have to pay attention to all these type of things. Okay, so only this much on the quality management. So we will start a new topic in the next week. Thank you very much. Okay.